Hello all. Now let us see the concept of steps to write a free body diagram in the Newton's laws of motion. This is most important concept for the not only Newton's laws of motion. In keeping you of almost on any entrance examination, the weightage is large. Okay, let us see one by one. Step one: identify the object in the given system and isolate it from the others. That means whatever the problem given in the examination, you have to identify the object, either pulley. So what are the examples you have to consider? What you identify? Either a string or like a pulley or like a block or any etc parameter given or inclined plane, anything given. Take only one unit. That's it. Now what you have to do? You have to isolate it from others. That means whatever the block you consider, you keep it outside. Second, indicate the non-contact external forces in the figure. In any figure, gravitational force never give you in the vertical downward direction. So you have to identify that one. In the given picture, what is the direction of gravitation force? Indicate all contact forces clearly in the figure. And whatever the contact force is given, either may be external force, frictional force, normal reaction, any other inclined directions, whatever given, you have to identify clearly in the figure. These are the three important steps what you have to write down. That's it. And finally, you have to give the final acceleration depending on direction of motion. Anyways, let us consider some examples. Example 1. In the example 1, there is some block of mass m1 over the rough surface and another block m2 happily suspended under equilibrium condition such that the entire system is connected from the string. I would like to prepare just only free body diagram for this particular case. That's it. I don't want to solve anything. Okay, only free body diagram. So in this case, first I am choosing for m1. According to step 1, I am taking for the block of m1 here. Now I am identifying what the gravitational force of m1g acts in the downward direction. Contact force. Normal reaction acts in upward direction, backside. Because the system is in rest, therefore static friction comes into picture, and along this direction, tensional force acts. Similarly, for the block of mass m2, the free body diagram will be like this. Gravitation force of m2g in the downward direction, tensional force acts in upward direction, and acceleration is 0 here, acceleration is equal to 0. Like this, you have to indicate the free body diagram for the respective cases. In this case, I want to consider first the pulley in the figure. When you take the pulley, two forces are acting in the downward direction and one force acts in the upward direction. Say it is T naught and T and as well as T. Take the value of M1. So for M1, what happened? M1G in the downward direction, tension in this upward direction. No doubt M2 is more in the figure compared to M1. Therefore, this block, heavier block will comes downward, lighter block will go upward. Therefore, acceleration A in upward direction. Come to second case. The heavier block of M2 acts gravitational force in the downward direction and the tensional force acts in upward direction, acceleration in the downward direction because this particular block coming in downward direction. Like this, you have to indicate free body diagram. Next. Okay. Example number 3 and example number 4. Now here in the example number 3, a block was fitted between the V shape of some figure. In such a case, what will happen? Let us see. In the given problem, by looking carefully, this is the first normal reaction, say N1, and this is another normal reaction N2. From the center of mass, okay, gravitation force acts in downward direction. Therefore, when you prepare free body diagram, vertically down gravitation force, along this direction normal reaction N2, along this direction normal reaction N1 acts on the system like this. Take the value of a free body diagram for MA. In this case, example 4, gravitational force MAG in the downward direction, contact force N1 acts in the upward direction. Take the second block. Now on the block, what happened? Gravitational force of MB into G acts in the downward direction and a normal reaction exerted by the earth over the block in upward direction N2 and a gravitational force by the first one on the second in downward direction. Therefore, you can write down as mag in the downward direction. Since object is not moving, therefore acceleration a is equal to 0, 0. In this case also a is equal to 0. Here we can apply Lami's theorem to find out n1, n2, and here they can ask you what is the normal reaction quotient. Depending on the problem or number of blocks, you can decide. Like this, the simple cases can be explored. In the next coming video or in the next coming class, we have completely free body diagrams for the different cases, and we will try to solve the puzzles. Thank you for watching my video. Please subscribe my channel for further updates. Jai Hind.